Dus werkt, hè? Ja. Is het zowel de microfoon voor de luidspreker als de telefoon? Oké. En waar komt het terecht, die video?
Op videocolleges.nl.
Oké.
Dat weet de student wel.
Oké. Oké. Ik wacht nog een paar minuten even. Lopen nog mensen binnen. I'm just waiting for people to come in, okay? All right, everybody, so welcome. This is the Bayesian Machine Learning and Information Processing class. My name is Bert de Vries. I'll be the responsible instructor for this class. I'm going to start with a poll just for myself. I would like to know your background because some of you, or probably a lot of you, are doing the AI and ES curriculum and you come from everywhere. So just for calibration of what I'm going to say, from which angle I'd like to kind of find out what your background is. So regarding your bachelor education, who did an electrical engineering bachelor? Like 30% maybe, right? So good. Just for myself, right? Who did a mechanical engineering? Oh, that's about the same, right? So that's interesting, like maybe 20%. And who did a biomedical engineering background? All right, 15%. So who hasn't put up his hand yet? Okay, so why did you yell a few things that you... Physics, who did physics? Physics, about 8, 9. Computer science? Still other backgrounds? Yell? Yeah, go ahead. Industrial engineering, great. Over there? Same, okay. And? Mathematics, yeah, sure, great. So everybody is welcome, and I think you all have a good background for this class. There's nothing this is of course a class in the electrical engineering department, but I don't assume any electrical engineering background. In fact, I don't assume any real background other than some maturity in engineering. And because even the basics, the probability theory, which we will be using in this class, we're going to review. And so the math is not too complex. It's actually going to be very elegant, I hope. And so don't worry about your background. The background is going to be totally fine. So what is this class going to be about? Well, let me first tell you where do I get this from. This is from the home page. The home page of the website. I think you should be able to get it if you go to bimlib.nl. Because I tried to forward it from there. So HTTP. That's the homepage. Bayesian machine learning, information processing, right? So can somebody check if that works, that link? That works fine? Okay. So that's the homepage of the class. And all the materials for the class, this is your portal. You can get everything from here, right? So later in this, on this page, you will see a table. And so the table basically contains everything we're going to do, and so the lecture notes of which date, exercises, assignments, and hopefully I can put even links here for video recordings of this class, right? So that if you happen to miss a class, you can go to the video recording. So today is obviously not going to be a very strenuous class. I'm just going to tell you what we're going to do. Probably don't make it to 4:15. Well, I will make it to 4:15, but I'm not sure if you need the second lecture. More generally, I don't intend to teach bullet by bullet by bullet for 2 hours, right? First of all, it's already 3:30, and most of you are ready to go home. And if I know from experience, if I would do that, then I'm not, I mean, I have 4 people here after 3 weeks. So I'm just going to be here mostly to, I'll give generally a recap, 20 minutes, of what I think are the main points of the class, and then I'm open for questions. And generally, from my experience, that means we do one hour and 10 minutes, 20 minutes, or something like that. Yeah, so that means that I really ask you to read the lecture notes before class, right? Because I will not go, I mean, you can read it yourself. I will not just stand here and read line by line. You can do that yourself, right? So, but if you read the lecture notes before class, and you will have questions, maybe not. If you don't have questions, well, why come here, right? But don't waste your time. But if you have questions, just come here, ask the questions in public so everybody can hear your question, and I will also answer it for everybody. And then, as we will see, there is a second opportunity, and we'll do that through a site, Piazza, which is a really great site where you can collaborate on answers on a web page. And I will go through that today as well. I'll just go a bit through this website, talk you through it. So there is a site, aside from this site, we'll use Piazza. Piazza, I'm just going to click on it and see if I'm going to get it. Yeah, I'll make it a little bigger if I can, yeah. Okay. So this is the Piazza site, and here you can post any questions that you have in the class. I will open the Piazza site for last year's, which is this one. And as you can see, and it just when I go through the weeks of the class, people ask questions, right? Here on top, these are folders. This is the BERT 3, my third lecture on Bayesian machine learning. And here are the questions. Log evidence, right? So somebody asked the question here in the TOS code example, why does the log evidence decrease? In my opinion, should not be the behavior of the models, blah, blah, blah. And then I give you an answer, right? The answer is for everybody. Everybody can read this, 49 views. Ideally, if you ask a question, though, let's see if this one. So here's a question. No. I want to get the question where the students collaborate in an answer, because this is the no. Let me go to another one then. Collectively exhausted. Okay, so you ask a question. You can ask the question anonymous. It will not be anonymous to me, but if you want, it can be anonymous to the class. But you can also, your name can be, it doesn't really matter, right? And then I will say, or somebody from the instructor staff will say, I love this question. And then you guys collectively work on an answer. Everybody can edit this, right? If the instructor, myself, or I will go through the other instructors of the class, we think this is enough, we'll just say, good answer, done. And then, so you have the answer. If I think it deserves a bit more, another answer or a bit more explanation, then I'll add my explanation here. There can be follow-up discussions, that's also fine. In the end, any question that you have about this class should not be left unanswered, either in class or here. This is asynchronous. You can, when we are in week 6, you can still pose a question about a class in week 4 and in week 3. It's fine, right? I'll wait a few days, see if you guys collaborate on an answer, and then if I think it's fine, then I'll endorse it, and otherwise I'll give the answer. And so over time, when you read these lecture notes, when you prepare for the exam, you shouldn't have questions or open questions, because you get basically you get to talk to me here in class, and you also get to write to the whole class and to the instructors on Piazza. So Piazza, as you can see, you can do LaTeX, and please do. So to get equations nicely, right? This is really a very nice tool. Every time when we have the evaluations at the end of class, people say, yeah, Piazza was very helpful, right? Because when I'm like deadline for the exam, I can put, I just put the questions that I left in my mind, and then they get answered. So please read before the class the lecture notes, write down your questions, write them in Piazza, or have them answered here. Of course, when it's here, we get to do some discussion, right? We get to do interactive answer, which has also its advantages. Okay, but this was last year, and as you can see, I think if we do no filtering, maybe we go to the home page. I'm not sure. Yeah, so there were 113 posts, 491 contributions from students, right? 103 times the instructors gave an answer, and there were 119 students enrolled. Please enroll. I think there is currently around 40 students enrolled. So this is for this year's class. 48 students have been enrolled. Just enroll here, ask your questions, and it's really easy. This is a very easy tool. So this is a tool we will use a lot. You will use a lot also. This will really help you. So that's Piazza. Any questions about Piazza? No? Okay, good. Blah, blah, blah. So Piazza is done. How do I get back? Yeah, so we're back. Here's the home page again. So course summary you've read. News I will also post in Piazza, because it's very easy to post there, and you will get a notification. You can actually download the Piazza app to your phone, and you'll get a notification, oh, there's news. So you can just read it, right? Or when you post a question, you get a notification when somebody updated the answer or something. All right, so I'm the responsible instructor. The other instructor is currently in a meeting, is Wouter Kouw. He will do probabilistic programming, which we will do 4 lectures of, and then there are 3 teaching assistants. I see one teaching assistant there, Wouter Nuiten, and the other two are currently also, I think, in meetings, but you will meet them, right? So like I said, all the materials for this class, this is your portal, this homepage, you should get everything, right? You can, like as you see, this, I mean, if we go to, let's say, I take a random lecture, let's say Bayesian machine learning, B3. So you click on here, and it's just a web page. It's just a Jupyter notebook, right, that you can read, and you can do it that way, or you can just, or you can get the printout with all the notebooks collected together in a PDF. And I wish I could just go back without going through this window collapsing and stuff, but I don't know how to do that. Anyway, so there is you can download the PDF bundle of all the lecture notes from this link. So I think it's about 130 pages. But it's just a bunch of bullets and equations with space and pictures. So it's not a lot. It's not a lot, right? But you can download it, and you can also it's basically the collection of lecture notes here. Then there are two books, and these two books, the first book, Christopher Bishop, Pattern Recognition in Machine Learning, is really a classic book in Bayesian machine learning. I think it was the first real book in Bayesian machine learning. So this was 2006, so it's like 18, 17 years old. I think when it came out, it just showed everybody that, yeah, machine learning is awesome, Bayesian machine learning does it better. And hopefully I will also show you that in this class. And if you start, of course, I have lecture notes, so I don't have a lot of text because I want to bring it to you in a compact way. But the book, everything that I will talk about is also in Chris Bishop's book. Well, not everything, but almost everything. And you have, if you like to read more background, that's a really good resource. Since it's like 17 years old, it's still very current. I mean, nothing is really outdated, but now it's also free. So this link will get you to Chris Bishop's website, and you could just download a PDF. Right? There's also a hard copy if you can buy it. But Ariel Katicha, Entropic Inference and the Foundations of Physics. I think he has a fantastic introduction to probability theory. That's why I put it there. Also a good introduction to the principle of maximum entropy, which we will talk about later. Of course, this is not a physics class, so most of that monograph that's there, that's not a book, it's more of a monograph that he didn't publish yet, but most of it is not relevant for this class. But in the class, we will mention the relevant parts that I think are very well written in that monograph. We will do some programming. And so it would be good if in the next week or so you get yourself a working version of Julia version 1.9. Now Julia is not Python, right, and not MATLAB, but it's very close. It's very close. It's also open source. Why do we use Julia? Well, I think it's good for your education to get acquainted with actually a much better scientific programming language than Python. Python is great. It wasn't intended for scientific programming, right? So Julia is a lot faster. The tagline of Julia is come for the speed, stay for the experience, or something like that. The syntax is very close to MATLAB, but the speed is very close to C, right? Out of the box, without compilation, or without toolboxes or anything underneath. So it's really a cool language. You don't have to become really good at Julia. The programming we do is very simple, It's almost like programming in MATLAB. The other reason is we have a very cool toolbox that we develop here in-house at the university that's written in Julia, just because it's a great language for scientific programming, for machine learning. And so I would like you to use that toolbox. And that's why we use a bit of Julia, which also means that you get a few weeks to just learn a little bit of Julia. It's a little bit, right? It's just some syntactical differences between Julia and Python or Julia and MATLAB. That's all you really need to know. It's not a big deal, I hope, but from experience, it wasn't a big deal in previous years. So what are we going to do? I'm just going to walk a little bit now through the next, what is it, like 8 weeks? How many weeks do we do? I think like 8 weeks, right? So today we do core syllabus, which is what we're doing right now. And in the second hour, machine learning overview. That's really simple. I mean, I'm not going to talk a lot about it. We'll do something about that, but that's you'll just read it once and there's nothing there really. Then the next 2 classes, so 17 November, right? This one, probability theory review, and next Wednesday, Bayesian machine learning. This is the real theory of the class. These are, I think, the 2 hardest classes. The probability theory review is in principle no different from the probability theory that you had in high school. It's just 2 rules, really, sum and product rules, and apply them to simple toy problems. But we're going to have a different interpretation of probability theory. It's just semantics, the Bayesian viewpoint, which is going to be interesting and very powerful. But the math, we're going to review it anyway, is not going to be very difficult. Then the application of probability theory to machine learning is called Bayesian machine learning. The term Bayesian stems from Thomas Bayes, who came up with Bayes' rule, and you may remember Bayes' rule, but of course we'll treat it as well. It's the core rule of machine learning, and so we'll go over why it is basically the core of machine learning. And so Bayesian machine learning is just named after Thomas Bayes. It's basically, it means that it's a commitment to using probability theory for all the reasoning that you do in your machine learning algorithms. Factor graphs and sum product algorithm is a way of computing answers, of doing machine learning, of the process of executing Bayes' rule, if you will. Right, so we'll do that next Friday then, yeah? So not this Friday, next Friday. Then I hope you have, you can download this assignment. The assignments aren't very difficult, really, but just get some practice in Julia. Then we'll do 2 classes on regression, basically, continuous data and the Gaussian distribution, and discrete data and the multinomial distribution. The Gaussian distribution, of course, the Gaussian distribution is a really core distribution in probability theory. And for discrete data, the multinomial distribution is sort of its counterpart. And you can already do a whole lot in machine learning just with these 2 distributions. And we'll just go over what the equations look like to do all kinds of interesting things just with Gaussians and just with the multinomial distribution, right? It's very basic. And then you'll get the first class in probabilistic programming, and that will just be dealing with how do we compute with Gaussian distributions. Now, what is probabilistic programming? In regular programming, you have a variable and you say this is a float or an integer, and you give it a value. Otherwise, you can't execute. You can execute the program. You have to give your variables a value. In probabilistic programming, you can say, Well, here I have a variable x, and I know it's distributed by a Gaussian distribution. Right? So I don't know its value, but it's drawn from a Gaussian distribution. I have uncertainty about its value. And then I want to compute x plus 3. Well, y equals x plus 3. What happens? What is y now? Well, y is also a Gaussian distribution. And so if you do computations with variables and your variables don't have values yet, but they have, I mean, the values is associated with a probability distribution. That's called probabilistic programming. It's the core of information processing. We'll get to that. I mean, that's all, what information processing is all about. Just how information that you receive from the world changes your beliefs about variables, and beliefs are encoded by probability distributions. So how probability distributions change over time as you make observations in the world, that's machine learning or information processing. And machine learning is just a part of a special case of information processing, right? So that's what we'll do December 6th. Then we have 2 applications, regression and classification. And you know these 2 applications, right? Regression and classification are supervised learning frameworks. Regression is the same as curve fitting. You have a bunch of points and you want to throw a line through it, or you want to throw a curve through it, and what's the best curve? That's regression. And classification is a similar problem, but now let's say the map has to go to a discrete set. So that means the outputs is either an apple or an orange or a banana, and not a continuous value on the real axis. Now, until recently, let's say the generative AI started to gain traction, so it's only early this year, almost all the neural nets, all the deep neural nets were either regression or classification nets. Right? It's amazing. I mean, it's amazing what you can do if you just consider supervised learning, regression and classification. Supervised learning means my training set has both inputs and outputs and desired outputs, right? And it's amazing how many problems you can kind of frame in that way, right? Like speech recognition. If you have a large database of acoustic signals and let's say the words, well, you can train a speech recognizer that way, right? Yeah, so we'll do also some programming for that. Then, sort of then we are like, then it became, this is the first time when it becomes a bit more difficult. We introduce a new thing, latent variable models. Now, our models will have variables that are not observed. So not everything is just given in a training data set, but there are variables in our models, hidden variables, like hidden weights in neural nets, for instance, that are not observed. And variational Bayes is a way of still doing Bayesian analysis, cool probabilistic analysis, to make these models work. Then we're almost there, right? Another programming assignment. We'll go through the break, and if you recover from the break, we'll do dynamic models, which are hidden Markov models, and Kalman filters. Maybe you've heard of that, but that's for tracking systems. For instance, the Kalman filter is a filter that was used in the 1960s to track the Apollo flight to the moon. And without Kalman filters, they would have missed the moon. Then we go to the final class, intelligent agents and active inference. Now we don't just have a machine learning box. Machine learning is you have a box, the box observes data, and you want to train the weights so that the box is sort of a model of these data. But an agent doesn't just observe data, it can also make actions onto the world, right? Like a robot. A robot is an agent. Yeah, it observes data when it walks around, but it can affect its own database because, if the robot goes left, it sees a different scenery than when it goes right. So it sort of is in charge of affecting its own database, right? So an agent, we are agents, right? If I look left or right, it makes a difference in the data that I get, and it makes a difference in what model my brain is going to learn for modeling the world, because the brain is a model. We will talk in that class about that as well. The brain is a model of the world, of your sensory inputs. And we are in control of the data. We can move around. So we are agents, and in fact, as it turns out, so we want to build intelligent agents that do a task, right? I want to tell this robot, now, clean my house, right? I want to be intelligent enough to learn how to clean my house. And it turns out that all the Bayesian framework that we've learned, that maps straight onto intelligent agents. And it's actually just, as we will also see in that class, it's a very good model for how brains really work, because the theory that we discuss on January 19th comes from the neuroscience. It's based on the latest neuroscience on how brains work. So eventually we will talk about models of the brain, and then you go into the exam, and the exam is really easy. Yeah, it is. Look, I'll show you. There's here some of the previous exams. So let's see if we can blow this up a bit. It's multiple choice, right? So that means it's multiple choice. So I cannot ask you long proofs, right? Because I would have to give you the proof. So you're not going to have to prove stuff. Right, so a multiple choice exam. Even if you just say A, you have 2.5. We round it up to 3, right? So you can't go, yeah. I'm not even going to schedule it down. Really simple, but you just fill out this this sheet. It's easier than doing your driving license in the Netherlands, because that's hard. The theory is much harder than this one. This one you will pass. The passing rate is close to 80% in this class. So I think it's a difficult class, right? And we'll take the class seriously. But I think I don't want you to worry during the class every day, or the exam is going to be so difficult. So if you just follow the class, you read beforehand, you go through Piazza, you talk to me in class, you will pass this exam. I want you to pass this exam, right? Because I don't want to see you here next year again, right? So that's good, right? That the exam is relatively easy. I give you 2 exams with solutions. You also have to train exercises with solutions if you want. The exercises are a bit more quantitative. They're not multiple choice. They're from the time when I did, the class was very small, so I could actually grade the exams. But if there are 100 people, I cannot grade that, right? So now it's multiple choice. And so it's a bit more quantitative than the exam questions. I think the 2 exams are very representative of the total exam. We'll make it even easier to get to pass the exam in 2 ways. The assignments, A1, A2, A0. So I think A1 and A2, if you do them well, you can get maximum of 1 point, and so the written exam will be 9 points, and then you get 1 point for turning in the assignments in a correct way. Of course, if you don't turn them in, then your maximum is 9. And then there's another bonus idea. So so 9 plus 1 is 10, right? And that's it. If your grade is between 5.0 and 5.4, yeah? So we'll do it this way. Let's say less than 5.5, because I'll just give full grade, so 5.5 rounds to 6. So, but if it's greater than 5.0 and less than 5.5, I'm going to look at your Piazza involvement. All right? And you don't have to, I mean, asking questions is just as much involvement as answering, right? But I just want to see, okay, asking questions is also helping out people. You're helping out people by asking questions at Piazza. And you also help, if you don't edit some, if you look at it, then I know you've looked at it, right? Because I can see in Piazza, there's some statistics on students. If I feel like, yeah, you actually were involved in this class, you did your best, I'll round it up to 5.5, right? It's by discretion, it's a subjective score. There's no not coming back to me and say, yeah, but no. It's a subjective thing. If I feel like, you're 5.2, you missed it by 0.3, but you were serious in the class. I can see that because I recognize your face, and actually I see you in Piazza. I'll make it 5.5, and up, there you go. It becomes 6, and you pass. So your only danger zone is between 3 and 5. Right, that's your only danger. so how can? Right, so you're going to pass this class. Probably not Friday. Nobody will be here anymore. All right, so that's it. Any questions about? Yeah, go ahead, sir.
So if you go to the schedule.
Yep. Yeah. So you want to see those? They are from the Corona time, right? So this is, I mean, this website is from our lab side, right? So if you you see here menu, this is from our research lab at the TU here. If you go to teaching tab, you'll see previous years. So you can go to previous year, and it will look the same. The website looks the same. I'm too lazy to change it. But the table looks a bit different, and there's video guides. And so you can press on the video, and then you see a really handsome guy at YouTube talking about regression, right? And 21 minutes, you see? So I just, in these videos, I'll just summarize the class. Now, this is from the year 2000. So this is like, okay, we've done 3 more classes. Not much changes, but something may have changed. I'm going to do sort of a similar thing here, live, and it's being recorded. There will be links, so you can also just watch the this year's class if you want, right? But if you really want, you can go see the old one, the old lectures, right? Is that clear? So, and because it's recorded this year, that's why I'm not putting them up on our current homepage. I will put up links to these recordings, right? So you have the recent ones. Yeah.
Will the assignments be in groups or is it individual?
Individual. Sir, go ahead. I would look at the exercises before. If personally, the exercises is the part of the class that I'm the least happy about myself, because I think, I mean, the exercises should really prepare you for the exam, which means it should be multiple choice. It's not. On the other hand, it actually gives you more, more quantitative skills, right? So for insight, I don't think the exercises help a lot. For quantitative skills, it does help. I would certainly look at them and try them. If you're pushed for time, I wouldn't sweat it if you only can make 70 or 80% of the questions. But if you have any questions about the exercises, just put them in Piazza and we'll answer them. Very important, though, to read the lecture before you come to class, because I'm not going to teach the whole class here, right? I mean, there's a lot in the class that I think you will get from a first reading, and I'll just assume that you're going to be mature enough to that you're not here to please me, but that you're here to please yourself, right? So, somebody in the back had a question. No? All right, so any more questions? Yeah?
Any mathematics or statics or something subject that you ask us to look at?
No, there's no, I mean, we'll do the recap in the probabilistic programming or probabilistic theory class, which is Friday. So it's a bit uncomfortable, but the coming week actually is the most strenuous week of this class, because Friday we have probability theory, and I asked you to really read the lecture notes for probability theory, because I think it's a core class. Actually, also next Wednesday, Bayesian machine learning is a core class. From there on, we'll do models and do some examples, do some coding, and then towards the end, we'll start this variational Bayesian stuff, which is a bit new, and that's about it. But the next 2 weeks, if you get the next week, if you get the next two classes, you really understand them well, then I think you're also covered with that between the 3 and the 5. Then you're past that, right? So, yeah. So please read probability theory before Friday's class, and yeah, then you're set to come with questions, ask questions, or pose questions in Piazza. Any? So no. I don't care if you had a statistics class. I don't care. Yeah. Okay. So on time, right? At 4:30, I'll go through B1. That will be another 20 minutes talking about a bit of a taxonomy in machine learning. What is regression? What's classification? What's density estimation? It's something you would get also if you just read it at home. It's not something that is especially difficult, but I'll do it anyway, just for completeness. And so we'll do that at 4:30. It will probably take 15-20 minutes. So it's up to you to decide if you want to come for the second part. If not, then I'll love to see you Friday morning. But please, a few people stay so they're not just talking to the camera, right? Okay, 15 minutes.